Assalamu alaikum and very good day. Today we would like to do a presentations about aluminum alloys. So this is a table of contents for our slides.
Hi everyone, my name is Chong Kai Wei. My student ID is TL22012. Today I'm going to talk about aluminum alloys and its composition. Aluminum alloys is an alloy where aluminum acts as the predominant metal. On the other hand, the typical alloying elements are magnesium, manganese, copper, tin, zinc, and so on. There are two types of aluminum alloy. First, cast aluminum alloys. Second, rough aluminum alloys. Cast aluminum alloys are the alloys containing aluminum as the predominant metal and some other alloying elements. Whereas for rough aluminum alloys, they are a form of aluminum alloys containing aluminum as the predominant metal. About 85% of the aluminum alloys are rough alloys forms. As an example, in alloy 3203, the number 3 indicates the alloy is in the manganese series. 2 indicates the second modification of alloy 3003, and finally 03 identifies it in the 3000 series. That's all from me. Thank you.
A very good morning to everyone. Now I'm going to present my part, which is production for aluminium. Aluminium alloys are made by mixing aluminium with various other metals. Some increase the strength of aluminium, others make it denser, still others change its heat transmission properties. So first, metals which can combine with the aluminium is lithium. Lithium is the lightest metallic elements, can act as a substitutional impurity in an aluminium crystal. Second one is copper. Copper has been found to increase the strength of aluminium than lithium alloy. Followed by the third one, which is magnesium. The magnesium alloys are not quite as resistant to corrosion. This is because aluminum oxide forms on the surface of the pure aluminium while making a protective coating, but its formation is interrupted by the presence of impurities. Mixing lithium or magnesium with aluminum is not enough to make a stiff metal. In bronze, the large tin atoms make it difficult for copper atoms to slide along their slip lengths. In steel, the small carbon atoms fill interstices in the iron lattice, preventing the iron planes from slipping. Lithium and magnesium are not larger than aluminum, and if there are a lattice sites, they will not stop atoms from slipping. A process called precipitation hardening reduces the malleability of an aluminum alloy. The material is heated to a temperature below the melting point. This increases the amount of the impurity that will dissolve in aluminum. The alloy is allowed to cool at a particular rate and allowed to age for several days. Although the lithium or magnesium atoms fit in the aluminum lattice, it is not as strongly bonded to the surrounding aluminum atoms as a matching aluminum atom would be. There is some strain on the lattice, distorting it. Heat allows the impurity atoms to drift around in the crystal. When a few lithium atoms meet each other, they will bond and form a precipitate, a clump of atoms with a different lattice pattern. The precipitate blocks the slip planes in the aluminum lattice. The material with precipitate is significantly harder. So, the aluminum alloys may also be cold work, rolling and pressing distort grains and reduce their size. That's all. Thank you.
Hi, my name is Muhammad Khairul Hakimi, and now I would like to present about advantages and disadvantages of aluminum alloys compared to alternative materials. For the advantages, the thermal conductivity, electrical conductivity, and cutting performance of aluminum alloys are good. Second, the aluminum alloys wire shrink less, so it has a good filling performance. The third one, aluminum alloy has small density and high strength, and its ratio of tensile strength to density is between 9 to 15. When working at high temperature or low temperature, it also maintains good mechanical properties. And the last one is the advantage of aluminum alloy has a good corrosion resistance and oxidation resistance. Most aluminum alloys have good corrosion resistance in fresh water, seawater, concentrated nitric acid, gasoline, and various organic substances. Next, we would like to look at the disadvantages of aluminum alloys. So the first disadvantages of aluminum alloys is low hardness and at the same time wear resistance is also poor. The second one, the volume shrinkage during solidification is relatively large, about 6.6%. The third one, the coefficient of linear expansion is relatively high. And the fourth one, easy to stick mold. Need to strictly control the iron content in the range of 0.8% to 0.9%. And the last one is the melting point is also low, and the use of high temperature is limited for aluminum alloys. That's all from me.
Hello everyone, today I'm going to present latest investment of the aluminium alloy. There have been several recent investments in aluminium alloy, such as the development of new heat treatment techniques, new manufacturing process, and the creation of new alloys with improved properties. One notable development is the use of additive manufacturing in 3D printing to create complex parts with aluminum alloys. This allows for the production of lightweight and strong parts with intricate designs. Another investment is the use of twinning index plasticity (TWIP) steels, which has high strength and ductility. TWIP steels have been found to have a good combination of strength and ductility, and are being considered for various applications, including in the automotive and aerospace industries.
That's all from us. Thank you very much.